Alright, question 25. So this is an exam question, and I think this is actually pretty similar to the kind of questions that you might see on the upcoming exam. Alright, so it tells you there's a reaction that's catalyzed by an enzyme. It's got a Km, and so the Km is 10 to the negative 4, right? Then it tells you that in the presence of a certain concentration of enzyme and 100 times the Km, V0 is 200 nanomoles per minute. So this is kind of the first important thing to pick up on. If you're going to have a concentration 100 times the Km, V0 is probably going to be pretty much Vmax. So you can kind of read this as saying Vmax is 200 nanomoles per minute. So then you add a non-competitive inhibitor I at a certain concentration. Sorry, did I say inhibitor? I meant enzyme over here. And so if you add that non-competitive inhibitor I, V0 is 100 nanomoles per minute, which is another way of saying Vmax is 100 nanomoles per minute, because you know the non-competitive inhibitors decrease the Vmax, but keep the Km the same, right? I'm going to draw it over here. So while that looked like that, this is going to be the new kind of curve, right? With with a lowered Vmax. In fact, well, okay. Let's just say, like, I don't know, this is 100 times Km, right? This is what Vmax was, and this is what Vmax is now, right? Sorry if that was kind of confusing. But basically, it asks now, what do you think what is the V0 gonna be at Km, right? And the key to this is because we know that Km stays the same, the concentration of Km stays the same, and it's still gonna be the velocity at which the velocity at the concentration of Km is going to be like half of Vmax, right? And this is still Km, and we know that Vmax is now 100 nanomoles per minute, so it's been cut in half, right? So half of that, which is going to be the velocity at Km, is going to be 50. So the answer is E.